And thanks for showing up for the lesson on function notation. We're in Chapter 1, Section 7. If you need any additional help, feel free to read the book, Chapter 1, Section 7, on this same information. Today we're going to write functions using function notation, and we are going to evaluate and graph functions. Some sets of ordered pairs can be described by using an equation. When the set of ordered pairs described by an equation satisfies the definition of a function, the equation can be written in function notation. But you may be wondering or thinking, what was the definition of a function? Well, I'd be happy to remind you. A function is a relation where every input is paired with exactly one output. So here we have f of x equals 5x plus 3. The output value is f of x. The input value is x. F of x equals 5 times x plus 3. If we use numbers instead of a variable, and we look at the output value f of 1, there's a 1 in place of the x, so we can replace the 1 in the x as well as our input value. So f of 1 equals 5 times 1 plus 3. The function described by f of x equals 5x plus 3 is the same as the function described by y equals 5x plus 3. And both of these functions are the same as the set of ordered pairs x, 5x plus 3. So you'll notice how these things are the same. So if we have y equals 5x plus 3, we could get an ordered pair, xy. So another way to write the ordered pair, because y equals 5x plus 3, is to replace this y with the 5x plus 3 in the ordered pair. The same thing here. If f of x equals 5x plus 3, so f of x and 5x plus 3 are the same thing, then in the ordered pair x comma f of x, we could replace the f of x with 5x plus 3, as seen here. The graph of a function is a picture of the function's ordered pairs. But please note, f of x is not f times x, or f multiplied by x. F of x means the value of f at x. So f of 1 represents the value of f at x equals 1. So let's look at some examples. For each function, evaluate f of 0, f of 1/2, and f of negative 2. So our function here is f of x equals 8 plus 4x. So let's substitute each value for x and evaluate. So f of 0 equals 8 plus 4 times 0 equals 8. So, because we were asked to evaluate f of 0, we replace the x with 0 in f of x and anywhere we saw an x in the function. So then 4 times 0 cancels out to 0, so then we just have 8. F of 1/2, we've done the same thing. We replaced all of the x's that we see in the function f of x equals 8 plus 4x with 1/2. Simplify and we get 10. And finally, f of negative 2, again replace the negative 2, and you get 8 plus 4 times negative 2 equals 0. Let's look at a graphing example. For each function, evaluate f of 0, f of 1/2, and f of negative 2. So we have the same x values as our previous example, but this time we have a graph. So let's use the graph to find the corresponding y value for each x value. So for f of 0, we can see that point when x is 0, y is at 3. So we have f of 0 equals, so if our x is our input for f of x, then our y value is 3. For f of 1/2, so here's where x is 1/2, our y value is 0. And f of -2, so whenever x is -2, our y value is 4. The notation f of x. In the notation f of x, f is the name of the function. So the function is named f. The output f of x of a function is called the dependent variable because it depends on the input value of the function. The input x is called the independent variable. When a function is graphed, the independent variable is graphed on the horizontal axis and the dependent variable is graphed on the vertical axis. So here's a representation of what we just read. So if we have d of t equals 65 times t, you'll see d of t is the dependent variable because it depends on what the value of t, the independent variable, is. Sorry, got tongue-tied again. Okay, and then here's our graph. So let's graph the function. So we have all of these points. We have this set of ordered pairs. Here's the graph. So we have 0, 4, 1, 5, 2, 6, 3, 7, and 4, 8. Please note that we do not connect the points because the values between the given points have not been defined. A function whose graph is made up of unconnected points is called a discrete function. And you'll read more about this in the notes page that you got today in class. So let's graph the function f of x equals 3x minus 1. First, let's make a table. So if our x value is -1, we can plug that in for the x right there. So we have 3 times -1 minus 1. So that's -3 minus 1 is -4. If we plug in a 0 for x, we can have 3 times 0 minus 1. Well, that's just 0. So our f of x is -1. And finally, 3 times 1 minus 1. That's 3 minus 1, which equals 2. Let's graph the points. So here's a graph that I've already put together, so that way you don't have to see me write all messy on the screen. But we have all of our points. We have -1, -4, 0, -1, and 1, 2. And here we do connect the points with a line because the function is defined for all real numbers. And you can see that because this function right here, it's not just a list of points. It's an actual equation. It's an actual function. The algebraic expression used to define a function is called the function rule. The function described by f of x equals 5x plus 3 is defined by the function rule 5x plus 3. To write a function rule, first identify the independent and dependent variables. So let's look at this example. A local photo shop will develop and print the photos from a disposable camera for 27 cents per print. Write a function to represent the cost of photo processing. So let's let x be the number of photos and let f be the total cost of the photo processing in dollars. So we need to identify the independent and dependent variables before we can do anything else. So cost depends on the number of photos processed. Because the more photos you process, the greater the cost. It just makes sense. So cost is going to be 27 cents times the number of photos processed. So the dependent variable is the cost, and the independent variable is the number of photos processed. So let's replace the words with expressions. F of x equals 0.27 times x. What is the value of the function for an input of 24, and what does it represent? So f of 24 equals 0.27 times 24. Simplified is 6.48. The value of the function for an input of 24 is 6.48. This means that it costs $6.48 to develop 24 photos. Well, that's it, you guys. Don't forget, read the discrete and continuous worksheet and answer the questions on the back, just like we talked about in class. And I'll see you tomorrow.